All right, we're going to keep moving forward with our work on exponential functions. In this video, we'll cover some division properties of exponents with an introduction and some examples. So our main rule is what happens. It's a rule that helps us know what to do when we are dividing powers. And here's the rule right here. If we have x to the m over x to the n, so we're dividing, the bases are the same, the exponents may or may not be the same. We can simplify that down and do x to the m minus n. And x can't be 0, otherwise we'd be dividing by 0, right? So let's talk about y. Remember, a exponent is just a counter for how many times we're multiplying something. So if we have 3 to the 5th divided by 3 to the 2nd, according to our rule, we would have, let's get some better numbers here. Let's say if we had 3 to the 6th over 3 to the 4th. According to our rule, we would subtract those exponents, and we would get 6 minus 4 is 2, so that would be 3 squared. But one thing I suggest that you do all the time with exponents is if you're stuck, just write it out longhand. 3 to the 6th is 6 3's multiplied together, and 3 to the 4th is 4 3's multiplied together. And what can we do? We can cancel a bunch of stuff. So a 3 cancels, another 3 cancels, another one, and another one. And then what are we left with? We're left with 2 3's being multiplied, which is 3 squared. Okay, so this works also if we have sort of more 3's in the denominator. Okay, so in other words, if we're going to end up with a fraction less than 1, and let's take a look at it. If we have 3 to the 2nd over 3 to the 4th, we can still subtract the exponents, and we get 3 to the negative 2, which is 1 over 3 squared, which is a 9th. And that kind of makes sense. We sort of want more of our 3's to stay in the denominator because we started out with more in the denominator, and we only have so many 3's that we can cancel out based on what we have in the numerator. Okay, we only have 2 3's we can cancel out. All right, let's do some examples here. So first one hopefully looks straightforward. We have a couple 5's there, and we have some exponents. We can just subtract those exponents. 5 to the 3 minus 2, which is 5 to the 1, which is 5. Okay. Similar work here, although let's simplify the numerator first. Let's actually do a fair bit of simplifying first. And I think I want to do this in 2 different pathways, actually. So let's simplify the numerator to get a 5 squared over 5 to the negative 3. Okay, and then we can subtract, right? We're dividing powers, so we're using our rule, what's 2 minus a negative 3. So this is 5 to the 2 minus a negative 3, which is 5 to the 5th. Okay? An alternative way of doing this is, let's just apply our rules of exponents first, our rules of negative exponents first, and we get a 5 to the 3rd. The 5 to the negative 3 comes up top and becomes a positive 3, and then the 5 to the negative 1 goes down below and becomes a positive 1. Okay, so this turns into 3 plus 3 is 6 over 5 to the 1, and then we would subtract these two guys and get a final answer like we got before of 5 to the 5th. So that would be our solution, 5 to the 5th. All right, and like we've been doing, we can do this with variables as well. It doesn't have to just be numbers. And so one rule that you can follow is, I call it sort of the distributive property. Don't really think of it as formally the distributive property, but this too gets applied to both pieces in there, as long as there's only multiplication or division inside the parentheses. So here's one of the most common high school algebra mistakes, is to think that you can just distribute the 2 or apply the 2 to both pieces in there. If it's an addition or subtraction, you can't. We'll get to that in our next chapter. But if it's only multiplication, you're allowed to do that. And so this turns into a squared b squared over a to the 3rd b to the negative 1. And you can really kind of think of these you can treat these kind of separately. Okay, so let's deal with the A's first and then deal with the B's second. Okay, so a to the 2 over a to the 3 is a to the negative 1. And b to the 2 over b to the negative 1 is b to the 2 minus a negative 1. So we have negative 1 times a to the negative 1 times b cubed. And then let's send that a down below to get rid of the negative exponent. So we get a b cubed over a is my final answer. And lastly here, before we do some evaluation problems, we have another one with some variables that we'll be looking at. So, and again, like I was saying, we can kind of treat our numbers separately from our x's, separately from our y's. Okay, so 3 over 6, that reduces down to 1 over 2. And I'm not even going to write the 1 up top. We don't need to write the 1 if it's 1 times some other stuff. We don't need it. The x's, we have an x to the 1 over x to the negative 2. 1 minus negative 2 is 3, so we have an x to the third up top. And then the y's, we do a 4 minus 3, and we have a y up top. So let's write that a little bit cleaner. We have x cubed y over 2 for my final answer. All right, and then our next example here, let's do a little bit of evaluation here. And remember, that just means we're going to plug in. We're going to try to simplify as much as we can first. So what I see for this first one, I want to trade those y's, get rid of those negative exponents. And at the same time, I'm going to subtract the x exponents to simplify that. So I will have an x up top, just x to the 1. And then a y squared comes up top, and a y cubed goes down below. And then I can subtract my 2 minus 3, so I get an x times y to the negative 1, which is really x over y. All right. Of course, we still need to do our evaluation, and we'll just plug in. So this will turn into 1/2 over negative 3. And then we can think about what that means for fractions. So I'm going to separate this out a little bit. Let's zoom in a little bit here. 1/2 over negative 3 is the same as 1/2 times 1 over negative 3, which is a 1 over negative 6, and probably best written as a negative 1 over 6. So that would be my final answer for that guy. All right, and then for our last one today, looks like we have a negative 1 out front. I'm going to write that in so we remember it. A squared and some b's, and again, you can treat the a's and b's kind of independently and separately. So what you're going to see me do, I'm going to try to be a little bit more efficient here. I'll talk you through it, but I'm not going to show every step of my work. So I'm going to write a new fraction bar. I keep my negative 1 up top. My a cubed is going to come up top and turn into a to the 5th. And I'm going to have a b to the 6th down below because my b to the negative 1 gets sent down below. And now we can plug in. So we have a negative 1, and then a itself is negative 1 to the 5th. And then b is a negative 2 to the 6th. So you got to be careful here dealing with all these negatives, okay? One thing that you might not have realized is that and I'm going to be talking about this piece right here, if we just have a negative 1 and we raise it to an even exponent, we'll end up with a positive 1 because pairs of negative 1s will kind of match up with each other and turn into positive 1. So, but if we have a negative 1 to an odd exponent, it's going to be a negative 1. Okay, so up top, we're going to have still our negative 1, and then times negative 1 to the 5th is a negative 1 because it was an odd exponent. And then down below, similarly, a negative 2 to an even power is going to be a positive number because those negatives will pair up and cancel out. And so that ends up being 64 down below. So up top we have a positive 1, and down below we have a 64 for our final answer. All right, that's a good place to stop right there.